This is SAT Math Prep video 5, and today we'll be talking about system of linear equations. So a system of linear equations means two or more linear equations. If two linear equations intersect, that point of intersection is called the solution to the system of equations. So there are three scenarios. One where there is exactly one solution, which would look something like this. So both linear lines are straight, and it would have one singular point of intersection or solution right there. And there are two other scenarios where it has no solution, meaning those lines are actually parallel. And in a previous video we talked about parallel lines, and those parallel lines have properties of the same slope and a different y-intercept. Good. And the system has infinitely many solutions is the last case scenario. That means the line is the exact same. So this line is one line, and the other line is literally the exact same line. Meaning every point is touching, and it has infinitely many solutions. Okay. From the standard form of a linear equation, it looks something like this: ax plus by is equal to c. We can use this form to tell how many solutions an equation has. So ax plus by equals to c. When we have two of them, and now let's label them with the correct subscripts. So when we have a1 over a2 is not equal to b1 over b2, this has one solution. This means they intersect something like this, and there's one solution. Okay, the next scenario is where a1 and a2 are equal, but the y-intercept isn't equal, which is c1 over c2. And this means there are, oh no, this is not equal. And this means there are no solutions. And it looks something like this, with two parallel lines. Like that. And scenario 3 is where everything is equal. The ratios are all equal. And this means they are, in fact, the exact same line. And they have infinitely many solutions. Okay, good. Okay, and from the slope y-intercept form, if we had two of the same equations, y equals to m1x plus b1 and y equals to m2x plus b2, if m1 is not equal to m2, that means the slopes are not the same. This means these two lines will eventually intersect at one point, meaning there's exactly one solution. But when m1 is equal to m2, and this is scenario 1, scenario 2, when b1 is not equal to b2, this means it has no solutions and the two parallel lines. Good. Okay. Oh, why did I miss that? Okay. And then the third case scenario is when the b1 and b2 are both equal to each other, as well as the slopes, meaning it's literally the exact same equation. Okay. So quick recap. So for which of the following k values will the system of equations above have no solution? So no solution means the a values, the a ratio, we'll call it a1 over a2, is equal to b1 over b2, but not equal to c1 over c2. So first, this 2 over 4 has to equal to negative 5 over k. Okay, now let's solve 1 over 2, k, 1 over 2, negative 10. So k is negative 10. And for it to have no solutions and not infinitely many solutions, 1 over 2, the ratio that's common within this 2 over 4 and this negative 5 over negative 10, cannot equal to 8 over 17, which we just quickly tell by eye is true. This equation is true. Okay. That means the answer is D. Good. Okay, question 2. In the system of equations above, a and b are constants. If the system of equations has infinitely many solutions, what is the value of a plus b? So, since it has infinitely many solutions, everything has to be equal. Every ratio has to be equal. So that means we can see 5 over a is equal to negative 2 over b is equal to 3 over 6. And 3 over 6 is just 1 over 2. So 5 over a is equal to 1 over 2. And what we get now is a is equal to 10. And then negative 2 over b is equal to 1 over 2 as well. And what we get is negative 4 is equal to b. Or b is equal to negative 4. So then a plus b is just 10 minus 4, and that would be 6. So the answer is 6, which is a. It's ugly a, but whatever. Oops. Okay. Let's look at number 3. In the system of equations above, a and b are constants. For which of the following values ab will the system have no solution? So this means 3 over 6 is equal to 3 over a, and 3 over 6 is also equal to b over negative 4. So this is the same idea where 3a should be equal to b over negative 4 for it to have no solution. And this should also be equal to 1 over 2 or 3 over 6. So let's think about this. So have no solution, meaning that have no solution. So that means this is not equal. It's not equal to 1 over 2, but these two are actually equal. So this can be 3, and this can be negative 4, because these two ratios are the same. And yeah, that just makes sense. So if we look at the options, D is actually one of the options, but there are many variables. But we can plug in all the other ones. 1 doesn't work, 1 and 1 doesn't work, negative 1 and 2 doesn't work, and 2 and 1 also doesn't work. So yeah, 3 and negative 4 works. Okay, let's look at number 4. In the system of equations above, a is a constant. If the system has no solutions, has no solution, what is the value of a? So it has no solutions, which means that a over a minus 1 is equal to 3 over a minus 1, but it's not equal to 3, which is 6 over 2. And what we can do here is just write it out like this. And a is just equal to 3. These two can just cancel out. And yeah, that will just be your answer.